Hello, all, and welcome to episode number 2 of The Cutting Edge. I'm your host, Dr. Eric Moore, Deputy to the Commanding General here at DEVCOM. This episode will feature the mission at DEVCOM CBC and highlight the fantastic work our teammates are doing there. I'm joined by Mr. Mike Bailey, Director, DEVCOM Chem Bio Center, and Dr. Peter Emanuel, Senior Scientist for Bioengineering. Gentlemen, thank you both for joining me.
A pleasure.
Thank you.
So, gents, can you tell us about the unique mission of DEVCOM Chemical Biological Center and how it supports both the warfighter and the national security?
Yeah, sure. So at the DEVCOM Chem Bio Center, we do all sorts of biology and chemistry. It tends to be in the mission space of chemical biological defense. If you think about anthrax or sarin or VX, threats like that, we work in a variety of commodity spaces. Sensing, protection, decontamination, but that's not all that we do. And so that chemistry and biology mission, we try to broaden that out because almost everything that gets worked on anywhere in DevCom has some component of chemistry and biology to it. And so we'll talk about a number of things today that are very chemistry and biology related, but not squeezed into the narrower focus of chemical and biological defense. And so I think that contributes significantly and quite directly to the national security. We've had a number of examples where real life stuff happens in the world, whether it's Syrian chemical weapons or the assassination attempt in Salisbury or COVID or others, where the things that we are doing are directly impacting not just warfighters, but citizens of this country and people all over the globe.
That's awesome. So, for the teammates out there in the virtual world, actually, I've spent time at the Chem Bio Center as director for the center as well as research and technology, and I've known these fine gentlemen for quite some time. Mike, you and I actually worked together at Defense Threat Reduction Agency in the past. Peter, we've known each other forever. I used to fund you. You also were at the Office of Science and Technology Policy. Mm-hmm. So we've done a number of work together over the years. From your perspective, Peter, when you think about the work that goes on at the Chem Bio Center, I'd like to hear your perspective as well.
So first of all, thank you. This is a great opportunity to talk about the lab and what we do. I like to think about the CBC as a place where scientists and engineers solve problems. We're professional problem solvers, and they could go anywhere, but they come there. And so we do specialize in operating in toxic environments where there's dangerous things going on, but we use chemistry and biology to solve those problems. And I think what Mr. Bailey was saying was it's really a pervasive outreach. And so sure, there's a lot of defensive capabilities, protection capabilities, decontamination capabilities, but we're also involved in a number of other areas that is cross-cutting. And so later on, we'll talk about some of those efforts in biomanufacturing. But for the most part, I think the laboratory is about using research and development and turning those ideas into solutions. It's very much a hands-on environment at CBC. So I think that's what I really like about it the most. It's a problem-solving environment where you can prototype and see the outcomes of what you're doing. It's very satisfying.
So what you're describing, Peter, is really what it means to be a center, which I don't think is something that many people really have a true appreciation of. These are not places that have a very narrowly defined mission. We only work on a particular number of things for a very small subset of customers. It's not like that. If a center, any center at DevCom, is really going to be successful, it has to have other things that it's doing, whether it's with industry or academia or other governmental partners or international partners. Because when we do all of that work for NASA and the EPA and the White House and Germany and France and all the things that we do, then when the Army comes to us and has a problem that they need solved, we're able to leverage all of those other things that we do and bring all that knowledge and expertise and capability to bear on the Army's problem. And that's a part about a center that I think that we need to communicate more, how a center successfully and effectively operates. That external piece of it, which is largely reimbursable in nature, is a really, really critical part.
So when you look at the world around you, what are some of the emerging threats and challenges that drive kind of Kim Center's research priorities and technology development? You've been a mile wide and an inch deep sometimes, and sometimes an inch wide and a mile deep on different things. But when you look at the world, at large, what do you see the Kim Center being able to stand up the same way you have for the Syrian stockpile, Salisbury chemical attacks, etc.?
Yeah, so for me, it's all about keeping capabilities warm, and that we do research and engineering in the different commodity spaces, whether it's sensing or protection or decon or integration or other enabling functions. And you keep all of those things going because you know that someday that call is going to come. And for you, it came, and for your predecessors, it came. It hasn't for me quite yet.
Oh,
I
it's
mean,
coming.
the phone has rang, like they find stuff in different places and we have to go deal with it. But there hasn't been a major world event. But when I look at that landscape, I know that something is going to happen. It might be on the biology side, might be on the chemical side, might be in a very high-end conflict. It might not be. It might be terrorism, might be a crime of some kind, like you saw in Salisbury. But I know that no matter what that thing is, no matter what scale it happens at, so long as I keep those commodity spaces warm, doing good work, cutting edge research, doing the engineering, generate those prototypes, stay integrated with the soldiers, get those touch points going, like just keep that warm, I'm extraordinarily confident that when that phone call comes, we will do what we have always done, which is respond and respond effectively. We have great people who do great things. And I get asked quite often, what's the thing that keeps you up at night? I tell people nothing keeps me up at night in this space anyway. I'm extremely confident. I am much more encouraged and enthusiastic about the opportunities that exist in our space, of which there are many. And Peter's taken advantage of one of those opportunities. I mean, the biomanufacturing work is just an enormous opportunity for not just chemists and biologists, but for all of the DEVCOM centers, for all of the Army, for like everybody. It's a huge thing. And we keep that warm, keep those smart people engaged, and good things are going to happen.
I'm glad you brought up biomanufacturing because I'd like to kind of shift to that next. And Kim Center is doing groundbreaking work in biomanufacturing. Can you share more about some of the your recently expanded facility that I got to visit when you weren't there, Peter, so you didn't know I
Yeah.
had done it, but I promise you I was there, and how it supports both defense needs and the bioeconomy? You and I have been focused on the bioeconomy for quite some time now, and it is the next big economy, many
Yeah,
predict.
I mean, people talk about this biorevolution. They say over the next 35 years, we're going to shift from a petrochemical economy to a bioeconomy. We're going to be able to actually brew chemicals instead of doing them in these petrochemical distillation facilities. So the facility at Aberdeen was an opportunity just waiting to happen. Actually, the way it really started was a bunch of scientists went out for crab cakes, and we're all sitting around figuring, and we're like, we need to be able to scale up. We need to be able to go from grams to kilograms because we're a prototyping center. Well, one thing led to another. We ended up in a conversation with the White House and they agreed. And so that set in motion what has ultimately been a $50 million renovation of that facility. Totally modernized that capability, actually added the ability to be able to broaden what we were able to produce. And so I was just telling Mr. Bailey that facility right now is actually actively scaling up critical chemicals for weapon systems and defensive systems. And so people, they think about biology and they only think about pills and vaccines. And it's true that biology did just save the planet during the pandemic, but what they don't realize is you can ferment critical chemicals. You don't need to use oil. And so right now we're using these large fermentation tanks to be able to make everything from underwater adhesives to lubricants. One of the things that's really going to impact the Army is we're actually brewing up the critical chemicals in our energetics, in our munitions. We're running out of those supplies because of global conflicts that are consuming greater amounts of 155 rounds, for example. And so, over the next several years, DevCom CBC is going to play a key role in scaling up some of those bioenergetics. And so, rather than buying those chemicals from China, we're going to brew them up in America using domestic biomass like corn. And so, it's greener, it's cleaner, but most importantly, it strengthens DoD supply chains. And so CBC is the only facility that the DoD has. And so what's interesting for DevCom is now the Army and the Navy and the Air Force are all going to come to DevCom CBC because that's where they're going to be able to scale things up. And so it not only provides that capability, but it strengthens the Army's role and places us at the center of this developing ecosystem. It's really going to change, I think, the character of what CBC is considered across the DevCom family. So big opportunity, I think.
Yeah, and Peter, there's a part of that that I want to highlight in this discussion, which is the couple people going out for crab cakes and have an idea and it turns into something. There's so many examples of that. Maybe they're not quite all as large as biomanufacturing, but people shouldn't ever think that your job is just, I'm going to show up at work and my boss is going to tell me what to do. That's not how it works. There are people who have great ideas, innovative ideas about all sorts of things. And we have all kinds of mechanisms in place to turn those ideas into reality. And so our culture, our employees know that when they have a good idea, they have an outlet for that idea to turn into something else, turn into something big, something special. I think that's a cool thing that I would want all of the people listening to this, no matter where they are, whether it's a DevCom Center or somewhere in AFC or elsewhere in the Army, to know that that's how these places work. Like that you all were able to do that level of innovation and turn this into a real live thing based on a market analysis that you did to know where the area of market failure exists and a hole that we can plug, a niche capability that we can plug in a broader market. That's a really big deal, and I think an important part of the story that you just told.
There's another part of that story that Peter's not telling. Okay, so he had AFRL and NRL and various scientists. He had a meeting with all the STs, the senior scientists. And they were in there eating all the crab cakes. It's a seafood. I happened to be in there that day, and they didn't offer me one crab cake. I'm sitting over in the corner with Fred Berg eating a little shrimp basket or something, and maybe having an old fashioned or something. And they were going to town on all those delicious crab cakes. I remember that, Peter. All jokes aside, though. So when you think about, well, let's just go back to biomanufacturing for just a second. So this is part of the Tri-Service Biotechnology for Resilient Supply Chain Initiative,
yes,
TBRISC.
Yeah.
And that is a partnership within DevCom, right? And so you have some of the synthetic biology pieces being done by ARL.
It's actually a partnership. So this pipeline is really meant to accelerate. We need to be able to make things and get them into the hands of the warfighter faster. And so being able to scale from grams to kilograms inside the Army, that's the first step. The partnering with the other services so that they're bringing their ideas and their inventions to us so that we can scale them up and prototype them here. That's actually what the pipeline is all meant to be. I think that the opportunity right now is that we need to essentially accelerate a number of these things out into the community so that our senior leadership can see that biology is more than just pills and vaccines. One of the things I want to bring up is it's not this idea that we're going out and we're talking. This camaraderie is actually it's across all the laboratories, but at CBC I've seen it really a lot. You actually stood up an innovation council when you were the director, and Mr. Bailey has been a huge supporter of that. And the innovation councils, some of the best scientists serve a term, and that is where we actually come up with all the ideas. And so the innovation council will spin out ideas based on these conversations. The autonomous robotic decontamination system is a perfect example of that. That was a need that came up. People realized that was a big labor issue, and the idea of using a robotic system to remove the people from the loop. And when we went to do that, we approached the other labs. We went to GVFC because they're our robotics experts, and we went to ARL. They knew how to write the software to move the arm, and CBC knew how to actually do all the decontamination. And so now you've got all these different DevCom laboratories, And next thing you know, you've got a prototype that never would have been able to exist if one laboratory did it. But because of the Innovation Council imagined this and then reached out to all these other laboratories, we've got a string of these kind of larger than life efforts that wouldn't be possible at one individual lab. But now we're bringing everybody together. The other one was that forward deployed biomanufacturing effort. We're working right now to design with NASA and HHS and the DoD and DARPA a machine that will make food, fuel, and pharmaceuticals on the moon and in austere locations. And so this is something that also is coming out of the Innovation Council, supported by OSD. And so it's another example of how we're trying to look beyond this traditional chem bio mission and imagine what's the problem of tomorrow and what can we do today to position ourselves for 2040.
I'm glad you said that and you talked about space because when the Mars rover eventually returns, I guess you guys are supposed to be involved, aren't
It's
you?
yeah. I actually had me and one of our other scientists, Dr. Brooke Ahern, had the opportunity to design the sample analysis protocol with the an interagency community for those samples. So they're going to bring back 29 samples from Mars and they're going to drop them at Dugway Proving Grounds around 2029, 2030. And we are it's just one example of how people are recognizing the expertise at the Army labs. It's not something you'd expect that an Army lab is playing a role in helping to design a sample analysis for a Martian soil sample, but we're actually one of the best labs in the world at analyzing small amounts of sample and doing it in such a high fidelity manner. So of course it's not surprising that NASA would come directly to us, but it's just the variety of things we get to challenge our scientists with is mind numbing.
It really is. And you mentioned a moment ago a bit about the autonomous systems for decontamination. So I want to kind of go back into that a little bit. So you're leading innovative work in autonomous systems for decontamination and microsensors. What impact will these technologies have for the warfighter?
This is an effort that Matt Brown and Sean Funk are doing, and it's a great effort. The autonomous robotic decontamination system is going to dramatically reduce the labor that it is needed to clean off a tank that's been contaminated with a chemical nerve agent. It's actually also going to allow the people to stay inside the tank instead of getting outside and exposing themselves to the danger. So it's safer, it's cheaper. It's really going to fundamentally rethink the way we decontaminate our vehicles following an attack with a chemical agent. And so we're expecting to have some field demonstrations in the coming year on that with GVFC and ARL. I just went over and I saw the system the other day, and it's quite interesting, much larger than I thought it was going to be, but it looks quite capable.
That's awesome.
We were just out at Schofield Barracks in Honolulu visiting with the 71st Chemical Company out there. And a company like that has what are called pacing items, which are the kind of major pieces of equipment that they use to execute their mission. They have NBCRVs and they have an M26 decontamination unit, which is essentially a power sprayer.
It's a power washer.
That you put some liquid decon into, requires vast amounts of water. You have to get in your protective posture in order to execute that mission, and it's tough. There's thermal burden in those suits, and the system doesn't work good, and they're old, and the parts break down. And when we were talking to them about, hey, there's this new thing coming along that one is going to take the soldier out of the hazard, it's going to let you do this safer. Depending on the decontamination that's inside it, you might be much less reliant on vast quantities of water. So you're going to have, resource advantages there. They were pretty excited about it. Hopefully, this is something that those soldiers get to see during their time in the Army. And I hope that the continued investment happens that's going to turn this into a real live thing for soldiers. I do honestly believe that it's going to make their lives better. It's going to make them more mission effective. And therefore make the Army more effective.
So that one was actually, we also brought in the acquisition body on that, and they worked a palm line. And so that's actually one of the things that's really important is what we're trying to do is not only develop these things, but also get them up and sustained. And so by partnering with JSTO and the JPO, we're working from discovery all the way up to acquisition so that these don't end up in a dead end.
So, the acquisition valley of death.
Yeah.
And what I have seen throughout my time within the Chem Bio Defense Program, whether it be at DITRA or as the Chem Bio Center director, the Chem Bio Center is truly kind of that adhesive glue, that integrator between the S&T and the advanced development pieces that should have their, transition quarterly reviews, their IPTs, et cetera. But oftentimes it's our folks that do it. Now, what I didn't realize at the time is because we also have a lot of the matrix personnel that are supporting the PEO. That helps too. But I think that's important. So, how does CBC's toxicology research help protect the warfighters from chemical and biological threats? And what new capabilities are being developed in this area?
Go
What I,
ahead.
so, the one I want to talk about is this cell on a chip. All right. So in the olden days, they would do what's called toes up toxicology,
That's
where you would
true.
expose an animal, it may die, and then
Feet
it
up, feet
toes up,
down.
and
Feet
then
up,
you,
feet down.
yeah. So that's old fashioned. But today we're trying to get rid of the use of animals for a lot of our testing. And we're able to culture cells on these little silicon chips. And we've gotten so much better at it that we can actually do different kinds of tissue. And you can actually have heart that's beating, and you can see when it gets poisoned. You can have lung tissue, you can have kidney, you can have and so they interact with one another. And so we're gradually supplanting the need to use animals in our toxicological testing, and we're using these little chips. In fact, we're leading the way. I saw this new robot we're getting that was developed. It's actually a breathing robot. And so we can actually simulate how things are getting impacted in the lung. And so we're working with some of the leading companies. This new test apparatus that we're going to have is going to be unlike anything that exists on the planet. We're working actually with a commercial manufacturer, and that's actually typical. Companies will come to us and sign like a CRADA, and they get something. We get something. We get access to their technology before anybody else sees it, and they get unparalleled access to the infrastructure that we have that doesn't exist anywhere else. And so that robot, that breathing robot, and those cell on a chips, that actually is going to make a real big impact in the coming year. It allows us to be able to ascertain what used to take us a lot of money and a lot of time cheaper and faster.
I couldn't agree more. I don't think a lot of people understand that the work that you all do with your industry partners, your academic partners, it has tremendous impacts on the local economy, on and even national economy and internationally in some respects with some of the work that you're doing. So you do a lot in that technology transfer space. You have a number of CRADAs, collaborative research development agreements, and a number of agreements that
People are surprised, actually. They think that they don't understand that the Army actually encourages patents, encourages publications. I remember at the beginning of my career, people were telling me they're going to lock you in a lab and do, and I'm like, that's not the way it works, actually. My brother's a scientist, same kind of scientist at a pharmaceutical company. He's been doing the same thing for 30 years. I reinvent myself every 3 to 4 years.
maybe two sometimes. No, I agree with you 100%. And yes, we are in a world we do have, standards for tech protect, but, leveraging patent license agreements, leveraging our intellectual property, that entire space is so critical for us, not only producing warfighting capabilities, but also impacting our economies as well.
This is an area I think that is really misunderstood far and wide. When people think about the government and government employees, they tend to think about bureaucracy and hierarchy and people push paper around. That's not true in all of the places, and places like ours that do this research, do the engineering, generate these patents. It is done because it has what are called externalities. If I go back to economics class, very positive externalities where an Army researcher will do research in an area of market failure because a company's not doing that research. A company can't do that research. No one's doing it. And so the Army will step in, do that research. They will discover things. They will make inventions. They will patent that technology so that it can be licensed to a company who will commercialize that. And companies are able to, for quite reasonable fees, usually license that technology, commercialize it, boom, profit happens out in the wide world. The Army gets to use the technology too. The Army might have access to what's being commercialized. But that economic engine is really important that people understand that. The Army works best. It does its best research, its most effective research in areas of market failure where other people can't do it or won't do it. And so when the Army steps in and fills that niche, it's generating innovation that can then be leveraged by industry. And it's a hugely important thing. I think there was a really good sense of this back in the 40s and 50s in Bell Labs and all these places where like true innovation was happening at scale. That story, I think, has gotten lost recently. And I don't know that there's a real appreciation for what these government laboratories, what these organic labs bring to that national economic picture.
It's very interesting. I was listening to a podcast this morning with Neil deGrasse Tyson. As you know, there's been some press about he and Elon Musk having some challenging conversations these days, but he was really talking about the role of NASA or government funded research and initiatives versus industry and private companies overall. One is beholden to the stockholders, so they can be innovative to a point, but there has to be a return on investment. So for large changes and movements that occur historically, it's been governments that funded those things, whether you're talking the Great Wall of China, pyramids, cathedrals, etc. So I thought it's an interesting conversation. You just reminded me of that. So one of the things I wanted to discuss, and you just talked about being out at Schofield Barracks, etc. Can you discuss how CBC works directly with warfighters to test and refine new technologies, like some of the work that was done recently at MISPICS with the autonomous decontamination system?
Yes, we've had a number of things at MISPICS, and the autonomous decon is one. The military working dogs work is another thing that's happened out at MISPICS. But what the reason that we were at Schofield Barracks and on Oahu in the first place was because of an exercise called Beholder's Gaze, which the Chem Bio Defense Program put on in support of Indo-PACOM, so that we could make sure that Chem Bio Defense capabilities are up to snuff for the potential fight in that AOR. But there's many of these exercises and demonstrations and test events that happen where we're out and about with users, watching them put our stuff through its paces. And the feedback that we get is invaluable from those, because you can do all the laboratory testing that you want. It's not till you put it in the hands of a soldier that you're really going to see.
And they break it.
That's right. Usually
you want them
right.
to. And then
That's
we have this massive rapid prototyping capability, the ADM. And so I remember we were developing a sampling kit a number of years ago. We developed.
What does ADM stand for the audience? Additive manufacturing.
Yeah, the Advanced Design Manufacturing is what ADM stands for.
It's a PIF, Prototype Integration Facility. Sometimes it's called the ADM. Sometimes it's called our PIF. There's other PIFs.
So we basically developed this sampling kit. We made a small number, which you do. You take it out to a field test, and they're like, it's too bulky, this or that. Then we went back, we designed another one. I think we went through 5 iterations before we finally got it. Then we put a patent on it. Then we licensed it to a company, and then it basically ended up at all the airfields. But that's indicative of the way we typically will do it. We use our engineers to prototype up small numbers. We then get the feedback. We go back, we optimize it. Then we basically lock it down. We patent it, and then we license that out. And what's great is we have all that on the same campus. So we can do it without actually really having to leave. But then you get something like it's really complicated, like the autonomous decon. And then you've got to go to GVFC and ARL and be like, because that's particularly complicated. But the process is the same. With autonomous decon, we design it, we fix it, and iteratively we go through this design, build, test, learn. It's called the DBTL cycle. And so you go around 3 or 4 times on the merry-go-round and you got yourself a product. So
that's awesome. Mike, a moment ago, you mentioned military working dog programs. And so you support some of that. What kinds of capabilities and training aids are being developed to enhance this capability?
Oh, yeah, it's a great story that kind of harkens back to the, have smart people keeping capabilities warm, and you never know when it's going to get called on. So the idea of a olfaction, using your sense of smell as a detector is something that goes way, way back in detection sciences. The human nose and olfactory system is, one of the most sensitive sensing systems that there is. And in canines, it's even, step function, higher order, more sensitive. And so research was being done on this. And so we had a team of people in that particular branch who were doing their work, doing research. COVID comes along. Somebody has the idea, hey, you could use a dog to potentially determine if someone has COVID or if there's COVID present. Boom, let's see what we can do. Put some prototypes together, develop some training packages, develop training aids. They made devices so that a dog wouldn't have to be, directly in contact with the hazardous material. All sorts of cool stuff came out of that as a method to get military working dogs to expand the library of things that they were able to sense. And so now we have a partnership with the Provost Marshal General's office. This is that's the two-star who oversees all military police for the Army. Really updating and modernizing a capability that had really fallen on hard times. And so we work very closely with them. It started with COVID, but it's now moved into explosives detection, really any kind of chemical you can think of. You can print chemicals out on these tickets on a piece of paper, really novel idea. And this is because we have innovative scientists who have good ideas, and it leads to good things when the time is right. And so I think it gets back to the methodology that we use. Have smart people work on hard problems, and you never know when serendipity is going to hit, and bang, it's going to turn into something. Military working dogs, I think, a great example of that.
My favorite part about the military working dog is when they were shipping sweaters and shirts that people were wearing. They would bag it up. People that had COVID, they're like, "You have COVID? Give me your shirt." And they would bag it up and they would use it to train the dogs. And the dogs could pick up a shirt that somebody had been wearing if they had COVID. And so that was the early days that we were working with an academic on this. But you can train a dog to do a variety of things, and it's really interesting.
No, I appreciate that. I was talking to Dr. Patricia Buckley this morning, and we were talking about how she had to walk me off the ledge for dogs, and it just came from having a history of being a medical service corps officer and doing a lot of animal research, and dogs was the big no-no. And so it took some time, but I'm so glad we did because it really helped us during Operation Warp Speed, the pandemic, etc. So, and it's phenomenal that dogs can pre-symptomatically detect people who are infected with COVID.
Actually, they can also detect a number of diseases. If you
It's many
train
of
them.
It's true.
If you train them, yeah.
So this whole concept of biomarkers and how we can develop biomarkers based upon dogs' olfactory, because at a certain point it's chemical in nature,
It's
chemical and neurological.
the volatile organic compounds. Yeah.
Yes, yes. So this is very interesting, and so I kind of wanted to talk to you about your world-class scientific personnel and some of your facilities, and how do you attract and retain top talent while fostering a culture of innovation?
Well, I'll let Peter talk to this in just 1 second, but the primary thing that I would say about that is that it's mission-based. You can do chemistry and biology anywhere. You can't do our kind of chemistry and biology anywhere. So we got a lot of people who come for the mission because it's special and it's unique. And they might not always have the best facilities to work in or the newest equipment. Sometimes they do, but not always. And so if we can get them, we can keep them with a pretty special mission. And so that's my take on it, Peter. I don't know what you would say to that.
I shouldn't. I'm sitting here with the deputy commanding to the general, and we actually don't have that much of a problem with retention. People, once we get them in, they stay. And we've been wondering what that is, and it boils down to what Mr. Bailey's talking about, which is we're doing things that are so unique. We see things that nobody gets to see. We have access to experiences that are just unheard of, and so people tend to come in, they stay, they settle. And we live in Harford County. We're one of the Aberdeen is one of the largest employers in the region. People tend to stay. It's a good place to grow up. It's a good place to build a career. And with the ability to detail, we don't have a retention issue. What's interesting is we also give people the ability to take ownership and direction of their research. And so the autonomy also plays a large part. I've had the benefit of working in 6 or 7 labs throughout my 3 decades of federal service, but I keep coming back to DEVCOM because of the latitude, because of the ability to have some say in where I go and what I do. That is not actually a universal thing. And so I applaud the Army for creating that culture.
I love it, gentlemen. I too could resonate with some of the same perspectives that you have in this regarding, people and how we hire people and get top talent. So you work, we mentioned this a little bit previously, talking about T2 technology transfer and just some of the work that you do with academia, industry, and even your international partners. But maybe a little bit more in terms of how these collaborations enhance your ability to deliver solutions.
Yeah, sure. So there's so many of these, and we've talked about a couple of them already. Uh, us generating a capability or a solution by ourselves is occasionally effective and will sometimes turn out something that's pretty valuable. That happens. More often than not, it's because it wasn't just our smart scientists, it was our smart scientists working with somebody in business who knows how to bring a product to life really well, right? If you're a profit driven entity, you care about bringing that thing along as quick as you can so you can generate profit, and having people like that in the mix helps us. It helps us to have access to world class scientists and researchers. Vanderbilt University, Johns Hopkins University, University of Maryland, uh, uh, Howard University, Coppin State University. Like, we have all sorts of universities of all varieties that we do work with, and it enables us to not just have the narrow focus that we might end up with just being Army people working in an Army lab. When you broaden that out, you're getting those new perspectives, you're getting those different viewpoints on the problem. That's where innovation happens, and I think that that's what drives it for us. That's the benefit of doing that kind of outreach with all those different partners. They bring something different and unique to the table that we don't have, and that's going to accelerate. That's going to drive innovation.
You've also had partnerships through TTCP, CBR, MOU with a number of our international partners. I ran into Dr. Jen Sikowski this morning, and we talked about when she did her ESEP, she was actually able to incorporate some of the
Yeah.
proteomics based mass spectrometry and bring it back and forth.
Yeah.
Some projects that Ditcher was doing again. Kim Bio Center was the integrator for a lot of that work. And now you have capabilities on both sides of the pond, the Netherlands, kind of our partners, and Kim Bio Center that we didn't necessarily have before by working together in those spaces.
I remember when she did that. She took her whole family over for that. It was like a year and a half, I think, to TNO.
Yeah.
I think we also had a researcher go over to DSTL in
Yes.
Salisbury for quite some time. The One of the things that while you're touching on is our international outreach is really a perk. Number one, it's incredibly helpful to basically be able to interact with our peers and exchange information, accelerates the technology. But for example, I'm about to kick off a NATO group on biomanufacturing for national security materials. It's my third NATO group that I've chaired. It allows us to really level set what our technology is doing with the Europeans. This one's a particularly interesting one because we're being directed to establish multi-year collaborations with our NATO allies. And so the CBC is a world-class laboratory, and our scientists are not only be able to interact with all these domestic academics, but we're now basically establishing these relationships with our NATO peers, our Five Eyes, and it allows us to essentially increase our interoperability with our allies. So it's a great perk. I enjoy it.
That is awesome. So, looking ahead, what do you all see as the most significant opportunities and challenges for CBC over the next 5 to 10 years?
I think opportunities, space is an opportunity. We tend to think of sensing in terms of a handheld device or a vehicle of some kind that's standing in the hazard. I think that technologies are going to come along that are going to enable sensing and detection from vast distances, potentially from space. I think that's one. Quantum sensing is another. We're just starting to get some work going in that area. Like, huge potential there. Standoff detection, like kilometer distance standoff detection, used to be the dream. The dream was given up on because spectroscopy modalities just don't sort of see that far. It just doesn't work. Quantum might. And so I'm not a physicist, and I don't like to talk to people about quantum entanglement because I don't really understand it. But what that enables us to do is pair up electrons and keep one here and send one way far away, and they act the same way when the one that's going far away interacts with something. That's that's a game changer. If we can figure out how to do that, and we're not the only ones working on that, industry's working on quantum sensing too, that's going to be pretty huge for us. And getting back to predictive toxicology, artificial intelligence, machine learning is going to take all the data that Peter was talking about that are coming off these chips and, not necessarily in the animal models. And you're going to be able to run artificial intelligence, machine learning algorithms on all that, so that when some new novel thing that we've never seen before pops up, we're going to have an answer pretty quick. And so those are a couple of the big opportunities, I think.
I'd agree with all that. I want to add on this. We have a large effort right now to really, over the next 5 to 10 years, to develop a biomaterials hub within the region. And so we look at the biomanufacturing that allows us to scale up all these new novel second, third generation materials, working with ARL down in Adelphi and up at Aberdeen. I talked about the bioenergetic space. What we want to do is expand our material science capability. We're working off post with some commercial manufacturers. We've established educational partnership agreements with 3 of the local universities. And the idea is that this pipeline, we want to make this a real thing. I envision having ARL and AFRL scientists embedded within CBC, working to mature these biomaterials from discovery all the way into application. And so I think that over the next 5 years, we're going to really push to see that come to fruition. That's going to be a real coup for us, I think.
I appreciate that. You both spoke about opportunities. What about challenges?
I think that the ease of making threat agents is a real game changer on the challenge side. Engineered biological agents are really a Pandora's box, and we've seen a little bit of that in the real world. Not a lot yet. Hopefully, we never will see a lot of it, but it just opens up a whole realm of, you have a biological agent, and I no longer know how it's going to act, and therefore I no longer know what countermeasures I'm supposed to use against it. Like, that's a big deal. The ability to, with the click of a button, generate tens of thousands of hazardous chemical agents has been done. This is in the literature. It's a thing that happens. And so the little short lists that we used to work off of are really no longer applicable anymore. There's just so much more in the threat space. But like I said, all these opportunities are coming along so that we're going to stay ahead of all these things. And I think that the opportunities outweigh the threats in this space. So you need to put a lot of brain power and money behind that on the weapons side. And so adversaries are going, if they want to do this, it's going to cost them. And a cost imposition strategy is often a valuable one from a strategic standpoint. And that's what we're doing by having the research capabilities that we do. It is a de facto cost imposition strategy on our adversaries. And that is a very, very good thing.
What about you, Peter?
I think our workforce is going to be a challenge. We've got a lot of people that have decades of experience that are nearing retirement. We need to bring in a lot of young researchers and expand out what we're doing. And so I think our biggest challenge is to keep expanding our capabilities, but not lose the knowledge that we've gained. And so over the next 5 years, I think the biggest challenge we're going to face is bringing in those new people, preserving that critical knowledge, and also identifying those critical areas where we want to move into. And that's a dynamic, because the lab can only be so big, and so that's a dance that I think Mr. Bailey is working really hard to meet over the next several years. So
I couldn't agree with you more. At AUSA, I've heard that the average age of an Army civilian is 47.
yes, I didn't realize
And
that.
at our center, well, I shouldn't say our center, DEVCOM, the average age is 47, 46.6.
Yeah.
So you round it up as 47. So we're right there with the Army, and I have the same kind of concerns that you have, Peter, but we're going to get through it, I'm sure. So I'd like to thank you both for spending this time with me today. It's been an outstanding, stimulating conversation. I always love to talk to my Chem Bio buds, and so great conversation today. So thanks everyone for listening, and be sure to check out the next episode of The Cutting Edge. As always, let us know what you think, what topics you'd like to hear discussed, and who'd you like to hear or see as a guest? Thank you.